Mr. Harridan here, and we're going to do some solubility curves. I know, I'm excited about solubility curves too. Okay, here we go. Below are some solubility curves showing us the solubility of several different compounds at different temperatures. Okay, solubility charts show the solids of the compounds expressed in grams of solute per 100 grams of water. It's very important. Okay, if you're using the graph, it has to read per 100 grams of water. Okay, this can be different depending on the chart. Also be aware that temperature in degrees Celsius here. Okay, so we're looking at the solubility of salts, solid ionic salts. Okay, what do you notice about the solubility of salts with increasing temperature? Okay, well, as the temperature increases, the solubility of solids increases. Okay, that's because solids look like this, and aqueous looks like this. Wee, woo. Okay, so you have to increase the energy, right, which is measured by temperature, to get it to aqueous, so the solubility of the solid increases. Now let's look at the solubility of gases. Here are some gases here. Okay, the solubility units are different, but that's okay, and this is the temperature. What do you notice about the solubility of gases with increasing temperature? The solubility of gases decreases. Okay, that's because when you have a gas, remember I go zoom, 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 and then when you get to aqueous, wee, woo, it takes away energy. So the solubility of gases decreases as you increase the temperature. Okay? Everybody good with that so far? On to page 13. Okay. Using solubility curves. Okay? Any amount of solute below the line indicates the solution is unsaturated. Below the line, unsaturated. Any amount of the solution above the line shows that the solution is supersaturated. Okay? The amount of solutes is above the line but not all dissolved. The solution is saturated with extra grams of precipitant at the bottom here. So you have to do subtraction to find the PPT. You have to do subtraction. That's basically what it's getting at there. Okay. Problems using the amount of solvent other than the given amount on the graph. Remember, the given amount on the graph is 100 grams. Can be solved by using proportions. So you're going to have to do proportions for non-100 grams of water. Okay? And then they give this example right here. Okay, all well and fun. Let's get down to the examples. Here we go. Are the following solutions saturated, supersaturated, or unsaturated? 40 grams of KCl completely dissolved in 100 grams of water at 80 degrees. This says 100 grams of water, so we can use the graph, so we're good. Can you even see that line? There you can see that line. Okay, so you go to 40 grams of KCl 80 degrees. My dot is right here on my graph. This is below the line. So this is unsaturated. Okay. Let's do the next one. 120 grams of KNO3 completely dissolved in 100 grams of water at 60 degrees Celsius. Okay, so again, we have 100 grams of water here, so we're good. Okay, so you go up to 120 here, 60 degrees. 120 and 60 degrees, the dot is right here. Okay, that is above the line. That would be super saturated. Remember, to make a supersaturated solution, you have to heat it to its solubility here. So I would have to heat it to at least like 68 degrees and then carefully cool it back to here to get it actually supersaturated. Okay. 80 grams of NaNO3, sodium nitrate, is completely dissolved in 100 grams of water, so that's a good sign. 100 grams of water at 10 degrees. 10 degrees, 80 grams. Oh my goodness, we're on the line. So that must be saturated. Okay, which of the salts shown on the graph is least soluble at 10 degrees? 10 degrees is right here. Let's see if the first line I hit. Oh, I hit the KCl3 line. So that would be potassium chlorate. Which of the salts shows the graph has the greatest increase in solubility as the temperature increases from 30 to 60 degrees? So I'm looking for the most change from 30 to 60 here. I can see that's probably KNO3 because it's the most curved. And which of the salts has its solubility affected least by temperature change? So which one is the flattest? That looks like NaCl. Okay, so there we go. You guys are champions.